I'm surprised that so many people want to come to a session on seaweed here in an inland city, but I'm glad to see you here. But I thought what I need to do to explain to you why I think seaweed is an important part of our climate response is to tell you where we are in terms of the climate crisis. So climate science is a very old science. It goes back to 1859 when John Tyndall in the City of London demonstrated that carbon dioxide can trap heat energy. By the turn of the 20th century, it was realised that if we increase the concentration of CO2 in the atmosphere, we will change the Earth's climate. By 1975, we had our first climate models, which gave us some certainty about what was going to happen as we added CO2. By 1992, at the time of the Rio Earth Summit, it was widely recognised that climate change was a critical issue that needed to be addressed. And President George Bush Sr. In the United States, at the Rio Earth Summit, promised the world a White House effect, as he put it, to counter the greenhouse effect. Now, sadly, those words were not put into action. And in the 30-odd years since 1992, we have seen half of all of the greenhouse gases ever emitted by our species put into the atmosphere. So in the last 30 years, we have doubled the size of the problem. Things continue on the same trajectory. Despite the Paris Agreement, despite the IPCC reports, the many warnings by people, we have not affected the trajectory of emissions growth. In 2018, emissions went up 1.7%. And the concentration of carbon dioxide in the atmosphere increased by a record-breaking 3.5 parts per million. That was just last year. This year, it looks like emissions will increase again. When I established the Australian Climate Commission in 2011, the very first report that we published was titled The Critical Decade, because we believed that unless action was taken in that decade, in the decade just closing now, we would be in serious trouble. And it turns out that that is, in fact, what transpired. No notice was taken of the warnings, insufficient government action occurred, and we are now facing a critical moment in the climate crisis. It's the moment when almost everyone on the planet, whether they realise it or not, is being impacted by our changing climate. And I just want to run through a few of the impacts that we are living through right now that you may or may not associate directly with climate change. The first, as an Australian, it's very much top of mind for me, is this plight of our coral reefs. Globally, coral reefs are in catastrophic decline. The largest coral reef in the world, Australia's Great Barrier Reef, is 80% dead due to bleaching and other impacts of climate change. The Arctic ice is facing similar peril. This year we saw a record low for Arctic ice in October, and we also saw very ominous signs of melting of the Arctic permafrost. For the first time ever, there were 10 separate readings of methane concentrations over the Arctic in excess of 2,050 parts per billion. This is completely unprecedented. No one has ever seen anything like this before. Russian scientists detected methane flares coming from the permafrost that underlies the Arctic Sea on a scale, again, never before encountered. These are very, very ominous signs that we are reaching a tipping point and that soon change will accelerate. We've seen very severe biodiversity impacts, including the first extinctions directly tied to climate change. We've had recent re-estimations of sea level rise. Until a few months ago, we thought maybe we'd be facing 0.5 metre to 1 metre of sea level rise by the end of this century. It's now looking to be more than 2 metres, with about 200 million people being displaced by those rising seas. Wildfires, any of you following the news anywhere, California, Australia, Greece and Southern Europe, will see how much more severe wildfires are becoming as change is being driven by the warming and drying climate. And drought, not just in Australia, but here in India. Water security is becoming a major, major issue. Temperatures are increasing, rainfall is changing. Sometimes we're getting big floods, but they run off quickly. We're not getting the steady rains of the past. And those sort of changes, I think, will really challenge us all into the future. And of course, what all of this means is that food security is ever more tenuous. We've been very good as a species at building our food security, but for the last 3 years, global hunger has been increasing as extreme weather events destroy our crops. If this is a new trend, and I fear very much that it is, we have something very, very important to worry about. The problem with the climate issue is that it is a juggernaut. It is a manifestation of unimaginable size. I talked before about human emissions, and I'll give you the figures, but you won't be able to comprehend them. I can't comprehend them. We are putting in between 50 and 60 gigatons of carbon dioxide equivalent into the atmosphere every year. Now, the only way I can try to explain the scale of this is to revert to something we all understand, like trees. You know, trees grow from their leaves. They draw in carbon dioxide from their leaves, they break the molecule apart and take the carbon to grow their structure. So looking at a tree, you can tell roughly how much carbon it's sequestered through its life. So how many trees would we need to plant to take just 10% of our current emissions growth out? So 5 gigatons out of the 50. We would need to plant an area the size of the contiguous 48 states of the USA and keep that forest growing for a century in order to take out just 10% of our emissions. The juggernaut of emissions growth, it's like an Amazon river worth of pollution running into our atmosphere every year. And the atmosphere is small and vulnerable. Our atmosphere is 500 times smaller than our oceans. And it is the atmosphere that we're polluting with this CO2, with the heat being transferred into the oceans. We are now at a point where we can't solve the climate problem just by cutting emissions. A decade ago, that was possible, and we could have done marvellous things if we'd started in 1992 with the White House effect, but we did not. What we have to do today to deal with climate change is both cut emissions as hard and fast as humanly possible, and we also have to get some of the gas out of the air. And every year that we leave this issue, the burden of greenhouse gases grows because that 50 gigatons, 1/4 of that remains in the atmosphere forever. It doesn't come out except through geological time. So the very notion of how we deal with climate change alters. Just as one example, we talk about offsets, and I believe it's a very good thing to do to offset your carbon miles from flying or whatever else. But the reality is that we are past the time of offsets. Offset says, what you say is, I'll put a bit of pollution up here and take it down here. We're now in an era where we have to cut that pollution and draw the gas out of the air simultaneously. So things change. The old debates that I hear still spoken about here in India, whether the developing world should wait for the developed world to cut its emissions, they just no longer apply. We are all in a leaky lifeboat. And if one group in the leaky lifeboat says, oh, we won't bail straight away, we'll wait until we help with the bailing effort, the boat will now sink. We have a short window of time. I think it's probably about 20 years in which to solve this problem. Otherwise, we will see the climate system, through positive feedback loops, tip into an alternate state which will be very difficult to get out from. So how does Seaweed work in with this? I was a judge on the Virgin Earth Challenge and looked at 11,000 entries, all of which were aimed at getting carbon dioxide and greenhouse gases out of the atmosphere. Some of them were totally mad. But of those 11,000 entries, there were 3 or 4 that were really scalable. One of them was seaweed. So why is seaweed part of the solution? First of all, seaweed grows very fast. It's not like a tree, as we see there. You know, the only really productive parts of that tree are its leaves. Its bark, its trunk and its roots are there to do other things. They don't actually work to capture CO2. Seaweed, the entire plant is productive. And as a result, it grows very fast. Seaweed grows 60 centimetres a day. And as that seaweed grows, it deacidifies the oceans. So it takes the acidity out of the ocean, creating a perfect environment for the growth of fish and shellfish. And today, the concept of ocean permaculture, that is growing seaweed and within the seaweed growing fish and shellfish, is a real growing phenomenon. It's a multi-potent solution that lets us capture the CO2 as well as feed an ever more hungry planet. It's estimated that if we can cover 9% of the world's oceans in seaweed farms, we can not only draw out all of those 50 to 60 gigatons of CO2 per year that we put in, but we can give each person in a population of 10 billion people, a future population of 10 billion, 200 kilograms of high-quality marine protein per year. So these are scalable solutions. But I ask you, how many floating ocean-going seaweed farms do we have in the world today? The answer is 0. So we're starting from a very low base. We know the solution is there. And I should just say, the other thing is, with the other big difference between seaweed and land-based vegetation is the security of storage of the carbon captured by those plants. So on land, if a fire runs through Bangalore, those trees will be consumed and the carbon that they contain will be released to the atmosphere. If they are subject to an attack by insects, the same thing will occur. But with seaweed, if we cut off the seaweed and sink it into the deep ocean, that carbon is sequestered for centuries, if not millennia, because of the slowness of the oceanic circulation. So we have rapid capture potential, multipotent solution, and sequestration. I'm not arguing that we need to use seaweed alone to solve this problem. We need to use every tool in the toolbox. But I believe that in future, seaweeds and the oceans will be a very significant part of our response to this growing climate crisis. I want to leave as long as I possibly can for questions, so I'm going to stop there and call for some questions. Thank you. Yes, I think you can.
Okay. My daughter's a marine conservationist and she's passionate about seaweed. We live in Goa. And she's really struggling with the idea of invasive types of seaweed, because I think there are some farms in Goa and in Tamil Nadu. She's worked with a community in Tamil Nadu. And she finds that there are these big multinational companies that are actually harvesting seaweed and using it for various things in India. But they are invasive types, which are really bad for the coral reef. So how does one solve this problem?
Look, thank you for that question. It's a very important one. There are many, many kinds of seaweed. Seaweed is arguably the most ancient multicellular organism on our planet. It's genetically extremely diverse. Seaweed can be used for many things, and there is a seaweed for almost every environment, whether it be freshwater or salt water. So we have to be careful, obviously, as we go forward. The key to using seaweed to address climate change is that the seaweed itself is not utilised for any purpose. Therefore, you'd pick the fastest growing native species in an area. What you would use is the high quality marine protein. The seaweed itself has to be sunk into the ocean depths. For that, we will need a carbon price. We'll need some sort of carbon pricing. We already have offsets that allow us to plant trees. I argue that under a blue carbon initiative, we could be framing things in a way that lets us have a carbon offset benefit. There is actually, in the US now, you can get a tax-deductible credit of $50 a tonne for sequestration of carbon. That could well apply to seaweed. So there are many economic means you can use to do this, but it's important to understand the principles that we're working with.
It's a pleasure to meet you, Tim. As we discussed before the meeting, so I'm very much, I like the concept of seaweed. As of now, I am working on plantation. So as I said, like in Bangalore, we are trying to set up a ornitho-ernobial tree park, where today we have started by planting 6,000 saplings. It's the process is going on. Today we have planted some around 200, 300 saplings. I would ask like whoever is interested to join for climate change, please join us. Please join us near Belandur Lake and try to do that. And for seaweed, sir, like how can we help? Like how can we bring awareness? And as you said, like more than trees, like seaweeds will help us to take carbon dioxide more, right? So
Yeah.
I would love to be the part of it, like and create awareness in my office where I work. So
Thank you.
how can we integrate? Yeah.
Look, thank you for that question, and could I applaud your efforts at growing trees? I don't mean to suggest that we shouldn't be planting trees. Clearly we should, because not only do they capture carbon, but they create benefits in terms of a microclimate and protecting our soils that are very, very important, and our biodiversity. In terms of seaweed, this is such a new idea that what we need at the moment is to socialise that idea. We need people to understand that there is the potential for using the oceans to sequester carbon, and that when governments are considering carbon offsetting or climate response legislation, that they keep that in mind and make sure that it's not just land-based carbon, but it is blue carbon as well that is factored into the regulations to give that industry the benefit of a carbon offset price, because without that we will not get the industry. Thank you.
Hi, I'd like to know how are governments and corporates taking on this idea, considering they are the biggest push, they're the ones who are going to give the push to this. So how are governments ready to fund this? Are they subsidizing it? What do you think is the long-term benefit? Possibility, sorry.
Thank you again. Could I say you're rather a privileged audience in that you are the first audience of a general nature that I've spoken to about seaweed. This is a very early stage idea. I gave a TED talk in July. You can look it up on the web, outlining the project. We've established a global foundation to investigate the project, but we are at a very, very early stage. We don't yet have an initiative with corporate backers, for example, to do this. We're at the science research stage at the moment. So it's early, but we need to start taking action, because unless we do, that 50 gigatons a year is going to keep building until the solution is out of reach.
Hello, I'm Atreya. So I'm a aquaculture consultant. In India, we have 4 species of seaweed. One is Capophycus, vulva, gracilaria, and the other one.
Asparagopsis, perhaps.
Asparagophyx, yeah. Which of these is a one species which can grow faster, because cost efficiency is one thing.
Yeah.
And to tell about, to second this, I was working in a firm where we used to import seaweed, which is from Norway and Sweden. So could you narrate about how this can...
Look, I didn't really have time to cover off on all of the details on seaweed I would have liked, but the fastest growing seaweeds generally are the brown seaweeds, so the kelps, the large kelps. They need cold water, but as you would know, 500 metres down in the ocean, there is abundant cold, nutrient-rich water. The surface waters may be sterile, but below there is cool water to grow kelp out in the ocean. Asparagopsis is very interesting seaweed. If you have it here in India, you're very lucky. Experiments done in Australia have shown that shandying cattle feed with 1% Asparagopsis on their licks, their molasses licks or whatever, gives you a 90% plus reduction in methane emissions. So very important. Ulva is used to clean water. As you may be aware, we use it in aquaculture in Australia to clean water. So in some of our aquaculture facilities, the water going out is actually cleaner than the water going in. It's also used to clean up sewage, human sewage, and you can then pyrolyse the sewage and create a very valuable fertiliser. So seaweed is useful not just for the immediate drawdown, but for many, many applications. And I think it's worth looking into what you have in the way of seaweeds here in India and working out how they might be used, as you're aware, I'm sure. We have freshwater seaweeds, saltwater seaweeds, many different kinds. They'll be in many environments.
I just have a quick question in response to what you were saying about what we need to do to cut down emissions, that we can't, we need to think of that as well. And actually, it's segueing from what you just said about methane emissions. So there is a huge, how does one actually, which is the biggest cause of methane emissions? Is it animal farming? And if so, how does one tackle that?
Yes. Look, the biggest source of methane emissions is wet rice agriculture currently, so growing rice in paddies. Cattle is important. Leaky gas infrastructure is growing in importance from fracking. But the biggest concern is the Arctic permafrost. And that seems to be, it's a very small percentage at the moment, but I fear very much it's going to grow quite rapidly.
So is it climate change also driving more blooms, seaweed blooms like golden tides and red tides? And wouldn't that kind of counteract this?
Look, climate change may be influencing those red tides, but the key factor that is causing those tides is an excess of nutrients. So just to give you an example, I'm sure that there are many Indian cities where sewage runs directly into the ocean, causing those tides. If you use seaweed in your sewage treatment plants to polish your water, in other words, get that water to a very high quality before you released it, you would have a crop, a seaweed crop there, which you could then pyrolyse for energy. So that's, not burning it, but it's heating it in an anoxic environment, give you energy, and then give you a very, very useful soil amendment, a fertiliser effectively. So this is, you're closing the loop by doing that. At the moment you have an open loop system where you're taking nutrients, you're paying for those nutrients, you're throwing them into the ocean where they cause another problem, and then looking up in horror. If we close the loop, we can actually have multiple benefits. There's a young person down here who wishes to ask a question. I'd very much like to hear from the young generation if we could.
Yeah.
Perhaps after. I'm sorry, we'll come back to you, sir. I'm so sorry.
You said in there are freshwater seaweeds and things. So in Bangalore, since we have a lot of lakes, is there something that we can plant in them?
Yes, in fact, I've heard about a lake in Bangalore here which is suffering from sewage, human sewage being pumped directly into it. If you had a seaweed race there using freshwater seaweed, you would be getting beautifully clean water out the end and you would have a crop. And just to give you an example, I'm involved with the aquaculture industry in Australia. In our farms, we grow many, many tonnes of fish and prawns a year, 1,000 tonnes of prawn a year. We have a seaweed race that produces 3 tonnes of seaweed a day, which is then used to turn into a fertiliser that we sell as a profit. So we can do that. We can clean water up. We have the technology to do it, and I'm surprised India isn't doing more of it.
I've written this down so that it's a little clearer. Like you have mentioned, the first step is to cut down emissions. The second step is to remove the carbon dioxide from the air.
Yeah.
But the third step, which is most vital, is to remove the carbon from the carbon cycle entirely.
That's right.
Because a dying tree or a burnt forest brings back the carbon back into the atmosphere and we're back to where we started. While seaweed is a great way to remove the carbon from the carbon cycle while it gets trapped down in the ocean, would other photosynthetic organisms like algae or moss on man-made lakes help? That's one question. The other is, are there other ways of converting these carbohydrates from seaweeds into other forms of carbon so that it is impossible for other companies and governments to reuse this carbon as like biofuel or things like that? Because that's back.
That's a great question, and it goes to the heart of the storage issue. There are some uses for seaweeds that would do that. So the development of plastics, for example, from seaweeds is one way you could store things longer term. The incorporation of seaweed into building products with the long life in our cities is another way that this may be achieved. Although seaweeds are hygroscopic, so they have to be specially treated in building materials. But you're quite right. We have to find ways of getting the carbon out of circulation. And with this excess carbon, that is a big challenge. So forests give us a temporary respite while the trees are growing, but then, as you say, they go back in. we have to find more ways of getting the carbon out. There are a few interesting chemical pathways I can talk to you about afterwards which offer those options, but it's a complex topic.
Your first solution is quite ironic and pretty controversial, which is to convert the seaweed into plastic, because that's another topic. But so just targeted to that.
Can I give you a figure on that?
Yeah.
So to get 1 gigaton of carbon out of the atmosphere by making plastics, we'd have to double the use of plastic bags globally. And who wants to do that?
Okay.
Okay, right.
Yeah.
But we could make chairs or parts of cars or something, perhaps.